Hi everyone, welcome to Solving Exponential Equations Part 2. So our learning goals are to solve exponential equations, and we're going to use the common base approach again. And we're learning to solve, particularly today, equations involving rational exponents. Okay, so that's going to be exponents that are fractions. All right, so solve each exponential equation. So 3 to the x equals 27 to the 1/2. So what we want to do is get a common base on both sides. So I'm going to ask myself, I'm going to ignore the half for right now. Can I write 27 as 3 to the something? So hopefully, based on our last day's work on fractional exponents, you know that 3 to the third is 27, and that's still to the 1/2. And then we can use our power to an exponent rule, which says to keep the base and multiply the exponents. 3 times 1/2, so 3 times 1/2 is 3 over 2. So now we have the same base on both sides, so we've got the common base, which means that for the equality to be true, the exponents also have to be equal. So if the bases are the same, the exponents have to be the same. So therefore, in this case, x would have to equal 3 over 2. Okay, and that's a conclusion we can draw, because if we have the same base on both sides, and that's all we have on each side, then the exponents have to be equal for the equation to be true. All right, so 5 to the 3x on this side. So in order to get a common base, first of all, I need to have the number in the numerator, okay? But also with this one, I have to get rid of the square root. So I want to write this in fractional form instead. So I want to write it as 1 over 125, and instead of square root of 125, I want to write it to the power of 1/2. So exponential form is really important here. So whenever you see a radical, when you're solving an exponential equation, you're putting it into fractional as a fractional exponent instead. Whereas the last time when we were evaluating, we were changing from exponential form into radical form. Okay? So it's the other way of thinking backwards here. So now I want 125 in the numerator. In order to do that, my exponent is going to become negative. So, again, what I want you to realize is that 1 over the square root of 125 is exactly the same as 1 over the square root of 125 to the 1 over 125 to the exponent 1/2, which is exactly the same as 125 to the negative 1/2. So we haven't changed anything, we've just changed what this side looks like, but it always means the same thing. Okay? We still don't have a common base. Our base on the left side is 5, and our base on the right side is 125. So the next thing we would want to ask ourselves is, could we write 125 as 5 to the something? And many of you may know that 5 to the third is 125. If you don't, use your calculator and try powers of 5. So you'd 5 squared, 25, no. 5 to the power of 3 would be the next one to try, is 125. So we replaced 125 with 5 to the third, but that's still to the power of negative 1/2. So then I've got a power to an exponent. So that rule says to keep the base and multiply the exponents. So 3 times negative 1/2 is negative 3 over 2. So now I've got the same base on both sides, which means these exponents have to be equal. So that's where I put my therefore statement. Even though that's not going to be my final answer, I'm stating that since I now have the bases the same on both sides, the exponents have to be equal. But the question wants me to solve for x, not 3x. So in order to do that, I would need to divide both sides by 3. And we know that to divide a fraction, you multiply by the reciprocal. So we have to go up here a bit. So that's going to give me negative 3/6, which we can then reduce to negative 1/2. So that's my final answer. X is negative 1/2. Okay, C, 4 to the x is equal to 1 over the square root of 128. So again, following the system here, we would rather write the square root of 128 as 128 to the exponent 1/2. Now we want to bring that up to the numerator. So we would write it as 128 to the negative 1/2. So now we're trying to match the bases. So I want to know, can I write 128 as 4 to the something? So 4 to the third is 64. 4 to the fourth is 256. So I can't write 128 as 4 to the something. So there has to be a common lower base, which was an approach that we used last week. Common lower base. Okay, so that common lower base is going to be 2. So I can write 4 as 2 squared, but that's still to the power of x. And I can write 128 as 2 to the, so let's try it out again. So 2 to the fourth, no. 2 to the fifth is 32. 2 to the sixth is 64. 2 to the seventh is 128. So I can replace 128 with 2 to the seventh, but that's still to the negative 1/2. So on both sides now I have this power of a power situation. So I know I keep the base and multiply the exponents on both sides. So now I'm finally at the point where I've got the same base on both sides, which means that the only way for the equation to be true is if the exponents are also equal. So that's where my therefore comes in. So I'm recognizing that since the bases are the same, therefore the exponents must be the same. But I have to solve for x, not 2x, so I need to divide both sides by 2. Dividing by 2 is multiplying by 1/2. So I end up getting x to be negative 7 over 4. And what does that mean? It means 4 to the power of negative 7 over 4 is the same as 1 over the square root of 128. All right, D, 2 to the power of x minus 3 is equal to 1 over the square root of 128. So 2 to the power of x minus 3 is equal to 1 over 128 to the 1/2, so exponential form. Now I want to bring the 128 up to the numerator, so the exponent will become negative. Now I want to get the same base on both sides. And in C, we previously just realized that 128 is the same as 2 to the 7th. So we're almost ready. We just have to do the power of a power on our right side. So we have to keep the base and multiply the exponents. 7 times negative 1/2 is negative 7 over 2. So now I'm at the point where I have the same base on both sides, which means the exponents have to be equal. So that's where my therefore statement comes in. So therefore x minus 3 must be negative 7 over 2. I have to get x by itself, so add 3 to both sides to solve for x. How do I add a fraction and a whole number? I need a common denominator of 2. Negative 7 over 2 plus 6 over 2 is negative 1/2. So there's my final answer. All right, E, 9 to the power of x is equal to the square root of 243. So I'm going to rewrite that first as 9 to the x is 243 to the 1/2. Now I'd want to see, can I write 243 as 9 to the something? 9 squared is 81. 9 to the third is 729. So I need a common lower base, which is going to be 3. So I can write 9 as 3 squared, but that's still to the x. And I can write 243. 3 to the 4th is 81. 3 to the 5th is 243. To the half. Now I've got a power of a power on both sides, so I keep the base and multiply the exponents. So now I've got the same base on both sides, which means that the exponents have to be equal. So 2x has to be the same as 5 over 2. But I don't want 2x, I want x, so I'm going to divide both sides by 2. Dividing by 2 is like multiplying by a half. So I end up getting x equals 5 over 4. F 7 to the x over 3 is equal to 1 over the 4th root of 343. So I'll start off with 7 to the x over 3 equals 1 over, right at the bottom, in exponential form, so it's going to be 343 to the 1/4. Bring the 343 to the numerator to make the exponent negative. Can I write 343 as 7 to the something? So I know it's not 7 squared because that's 49. 7 to the 3rd is 343. So 343, sorry, can be written as 7 to the 3rd, still to the negative 1/4. 7 to the x over 3 equals 7 to the, so 3 times negative 1/4 is negative 3/4. So now I have the same base on both sides, which means the exponents have to be equal. So therefore, x over 3 has to be negative 3 over 4. But I want to get x by itself. So this is x divided by 3, so I'm going to multiply both sides by 3. So that gives me x equal to negative 9 over 4. This is my answer. Okay, G. Okay, so you put a star around this one. It's kind of interesting. So we've got 8 to the 2x plus 1. First, let's write the denominator. So if you remember, x to the m over n could be written as the nth root of x all to the m, or there was one more that I put on there. This means the same thing as the nth root of x to the m, which is what this looks like. So that should mean if I want to write this piece in exponential form, I can write it as 16. So m is the exponent, 9x, and the root is 3. So that's 16 to the 9x over 3, which is the same as 9x divided by 3 is 3x. Okay, so now in order to get a common base, I need to have the 16 in the numerator, so I'm going to make it 16 to the negative 3x. And is it possible to write 16 as 8 to the something? Well, 8 squared is already 64, so there has to be a common lower base. Common lower base. So that common lower base is 2. You might think it's 4, but 4 squared is already 16, not 8. So you have to go even lower to 2. So we're thinking 8 can be written as 2 to the power of 3, but that's still to the 2x plus 1. And 16 can be written as 2 to the power of 4, but that's still to the negative 3x. And then we want to expand using the distributive property, this exponent here, because we have power to a power, so we keep the base 2 and multiply the exponents. 3 times 2x plus 1 is 6x plus 3, and 4 times negative 3x is negative 12x. So all that work got us to getting the same base on both sides, so that we know that the exponents would have to be equal. So we can say, therefore, 6x plus 3 would have to be negative 12x. But we want to solve for x. We've got an x on both sides, so that kind of brings us back to grade 9 here. Subtract 6x from both sides. Trying to get x by itself, divide both sides by negative 18. 3 over negative 18, if you divide top and bottom by negative 3, you'll get negative 1/6. All right, h. 4 to the x minus 5 is 1 over root 32. So we want to rewrite root 32 as 32 to the 1/2. Then we want to get the 32 in the numerator and make the exponent negative. 32 cannot be written as a power of 4. 4 squared is 16, 4 cubed is 64, so we need a common lower base. Which is 2, so 4 is 2 squared. 32 is 2 to the 5th. Then we want to do our power of a power on each side. So we want to keep the base and multiply the exponent. So 2 multiplied by x minus 5 is 2x minus 10. Be careful. So that distributes. And 5 times negative 1/2 is negative 5 over 2. So now we've got it to where the bases are the same on both sides. And the exponents are the same on both, or that they have to be equal. If the bases are the same, the exponents have to be the same. So therefore 2x minus 10 must be equal to negative 5 over 2. Add 10. So if we add 10 with a common denominator of 2, that's going to be 20 over 2, which is going to give me negative 5 plus 20 is 15 over 2. That's 2x. So we need to divide both sides by 2, which is going to be 15 over 2 times 1/2, or 15 over 4. I, 25 to the x plus 4 equals the square root of 125 to the 4x plus 2. So again, remembering this idea up here. So the root is the bottom number of the exponent, and the exponent is the top number in the exponent, or the numerator. So I can rewrite the right side here as 125. Remember, there's a little 2 there that we don't see, to the 4x plus 2 over 2. And 4x plus 2 divided by 2 is 2x plus 1. Can I write 125 as 25 to the something? No, because 25 squared is already 625, so there has to be a common lower base, and that's 5. So I can rewrite 25 as 5 squared. And I can rewrite 125 as 5 cubed. Then I have to use power of a power on both sides, so keep the base, multiply the exponents using distributive property. So 5 to the 2x plus 8 equals 5 to the 6x plus 3. Bases are the same on both sides. Exponents are the same then. So therefore 2x plus 8 has to equal 6x plus 3. So I'll get the x's together on the same side and the plain numbers together. So I've got 5 is equal to 4x, giving me a final answer of x being 5/4. Okay, J, 3/4 to the power of x is equal to 64, the square root of 64/27. So first of all, notice my base is a fraction here. So these are getting a bit trickier now. And I can rewrite this as 64/27 to the half. Now, if you notice here, right now the numerator 3 in this one doesn't have any powers in common with 64, but it does with 27. And same thing, the denominator 4 doesn't have any powers in common with 27, but it does with 64. So if I want to be able to rewrite the two sides with a common base, I'm gonna have to flip the 64/27 and make it 27/64. But if I do that, that's gonna make the exponent negative. Okay, and that's using the rule that if you have x over y to the negative m, that's the same as y over x. Can you see that? Yep, to the positive m. Okay, so that's one of our exponent rules that we learned on the first day that we talked about exponents. So, but we're using it backwards. So we have this 64/27 to the half, and we're rewriting it as 27/64 to the negative 1/2. So we were used to always going this way last week, but now we're going this way. And that's so that we can have the same base on both sides. So we want to be able to write 27/64 as 3/4 to the something. And it's got to be the same for the numerator and denominator. So if you know 3 cubed is 27, which it is, then 4 cubed had better be 64 or the question's not going to work. And in this case, it does work out. 4 to the power of 3 is 64, but that's still all to the negative half. So we've got 3/4 to the x, and now we've got a power to an exponent. So we keep the base 3/4 and multiply the exponents. 3 times negative 1/2 is negative 3/2. And now we've got the same base on both sides, which means that our exponents have to be equal. So therefore, x has got to be negative 3/2. Bases are the same, exponents have to be the same, and that already is solving for x, so that's our answer. So with k, 3/2 to the x is equal to the square root of 32/243. So first let's write it as an exponential form on the right. So 32/243 to the half. And again, we see that the 3 has powers in common with 243, and it's the 2 that has a power in common with the 32. So since they're opposite, we're going to use that rule again. So we're going to flip this and make it 243/32 to the negative 1/2. So for instance, I know that 2 to the 5th is 32. So I'm hoping that 3 to the 5th is 243. So I can check those on my calculator. 2 to the 5th is 32. 3 to the 5th is 243. That's all still to the negative 1/2. So then on the right side, I have to use the power to an exponent rule. So keep the base, 3/2 multiply the exponents, negative 5/2. So now I've got the same base on both sides, which means that the exponents also have to be equal for the equation to hold. So therefore, x is equal to -5/2. All right, so that was our lesson on solving exponential equations that involve rational or fraction exponents. So I can solve an exponential equation involving rational exponents using the method of common bases. Thanks.